Jan Ozer here from the NAB, I'd say show floor, but we're in a booth in the Brightcove booth. I'm with Yuriy Reznic, who is a technology fellow for Brightcove. Hey Yuriy.
My pleasure being here. Thanks for stopping by.
My pleasure. So one of the most interesting things that I'm seeing here at this NAB is the transition from content-aware encoding, where we encoded each file differently because of the underlying complexity, to more of a holistic look at not only incorporating the content, but incorporating the effective throughput to the viewers, what type of device they're viewing it on, and coming up with an encoding ladder that really makes sense for the entire infrastructure rather than just the content. And there's a couple of companies doing that here. Brightcove has been the most aggressive in my mind in both publishing about it and disclosing what they're doing. Yuriy has published some brilliant papers, and he had a discussion here at NAB, and he's going to tell us both what the multi-format delivery system architecture is all about, if that's the product name, and he's also going to tell us about the optimal ladder, kind of a smaller problem, but one that's dear to me, the optimal ladder for hybrid, either Dash or HLS streams that include both H.264 and HEVC. So we're going to start with the entire picture, and then we'll move to the second. Is that okay?
Yes.
Okay.
Sounds good. Thank you so much.
And I'm going to turn to a camera operator.
So what you can see here is a sketch of an architecture of the end-to-end delivery systems that we have. And at Brightcove, we call it Video Cloud, and this has been the very first online video platform that was invented as a category of products. And it's evolved, and it's been developed to include many additional technologies to live in the reality of multi-format, multi-codec world. So one of these technologies is a dynamic transmaxing, or what we call dynamic delivery system, where we actually don't encode video to different Dash or HLS streams. We encode them to intermediate representation, and then we transmax them dynamically. This saves dramatically in terms of amounts of data that we need to store internally, and we figured out how to couple it with CDNs such that the number of transmax operations that we have to execute is also minimized, and such that the whole system works very smoothly and reliably on a grand scale. But what makes things truly unique, and this is something we started doing a few years ago, and I'm actually delighted to know that many other companies now repeating same path, is that we started incorporating end-to-end optimizations, where we collect data from analytics to see what are the bandwidth distributions sending videos to different categories of devices, what those devices are, what the percentages of those devices are specific to each operator or specific to each geography of viewers. And once you know all those specifics of the context of the operator, of course you could optimize ladder to make delivery best for this particular operator. If you stream to somebody in India over very slow mobile networks, of course you would want to pick bit rates that are more densely centered around low bit rates, which will actually be used by this operator, as opposed to somebody in Japan streaming to TV sets where 1080p is the only thing you really need to worry about. So that's what we call context-aware encoding. We did it, the project started actually 2016 when we started working on this, and we shipped it in, I think, mid-2017, and it's been up on market for quite a while now. And of course, again, I'm delighted, the trend is, the world is reaching the masses, and we see other guys following. But it is, if you think about building whole system, it's not just profile generation, it's taking into account all entire end-to-end delivery process and doing it as specific to your delivery architecture and to the customer and operator, and coupling with CDNs as they set it up, because all those details affect statistics. All characteristics of CDN affect statistics, characteristics of how you connect them, geography, everything. So the system we have is highly flexible. It allows you to specify all these parameters, and it can optimize to every nuance of the system as you actually have in practice. So that's the end-to-end aspect of it. Do you have maybe?
So let me ask a question. So you're basically saying that if you were delivering to a high bandwidth country, you would change your encoding ladder to have a disproportionately high share of high resolution, high data rate streams, whereas if you were, as you said, if you were encoding for delivery in India, you would focus on the lower end and put more of your emphasis there. So, and that's not a real-time thing. I mean, that's after N videos, you have enough experience to start to fine-tune your encoding settings to match your delivery experience.
Absolutely. You need to measure statistics somehow. And if this is the operators that already been working in the system with some profiles, you just learn all the characteristics from analytics as data coming in, and you can measure the bandwidth using logs from CDNs, also from feedback from clients. Sometimes you need to correlate those data because client level analytics and server-side analytics don't match always. But that's really where the loop is getting closed.
So how would you measure overall success or failure of the system? Are you seeing, is it a higher, I'm sure it's a higher QoE, but how would you measure that?
It is higher efficiency at the end of the day. It might translate into better quality of experience if you network bounded, or it could translate into lower bandwidth costs and into lower CDN costs if your network is fantastic, but we just deliver highest encoding efficiency possibly. I actually have one slide to demonstrate it. Let me just scroll few. It's been a talk I was giving, so there are some details that probably not needed, but this is actually good. Hold on. Just one more. So this is example when we have three types of operators. One with very limited networks, about 3 megabits as average bit rate across different categories of devices, and most common category in this case is mobile. In the opposite end, it's an operator who is sending predominantly to TV sets, and his average bandwidth is 35 megabits, factor of 10. And when we do encoding, we compare to the Apple recommended profile, which has 9 ranks or 9 renditions, and you can see that for operator with best network, we generated only 5 renditions, and the reason actually the highest rendition is the only one that's really needed, but to stay by guidelines and have 100% increments between different rates and start with something very little, that's what we need to do. We need to insert few of these renditions, and the total number becomes just 5. So you're of course wasting some of the renditions, but you're wasting much less as opposed to the entire 9 rendition encoding ladder in the Apple default guidelines. And if you look at the profile for operator 1, which was bandwidth limited, there are more renditions, but they are more densely centered around lower bit rates, like 125 kilobits to 223, 398, and the resolutions are smaller there to enable such a lower bit rate. So completely different profiles. And then if we look at the savings that we achieve, these are relative savings. So if minus means we reduce, so the number of renditions goes down from 22% to 44%. The storage goes down, of course, for operator 3 even more because there are less renditions. But interestingly, bandwidth also goes down across, but non-uniformly. For operator 3, it's over 30% that we can save, because that network is perfect. It's only highest renditions that's being pulled all the time. The most you save on that rendition, that's what matters. But for operator 1, which pulls the mix of those renditions in the middle, the bandwidth saving looks less, it's about 8%, but then we look at average resolution, it's up by 27%. So we actually give much better quality in the context of this operator. And if you look at other characteristics like buffering ratio, startup times, they also get improved all across. So it's both quality of experience and savings in terms of cost of delivery. that we can bring in this context.
Are these theoretical numbers or are these real numbers?
These are real numbers measured for 3 different operators.
Okay, impressive. Okay, so let's go to the mixed encoding ladder, if you don't mind. So again, the problem that we're trying to solve here is we know that HEVC is playable by a broad range of both Android and iOS devices. How do we integrate HEVC into an encoding ladder so we can present that using both ABR formats? So that's a problem that you've considered. Have you rolled this out, or is this just something that's kind of in the nascent stage?
It is in trials. It is in state of going from research to production. But I can show demos.
Okay.
And but fundamental problem here is that yes, we have 2 codecs, but then not 2 categories of devices. There are actually 3 categories of devices that can receive them.
Right.
There is a category of devices that can only receive legacy H.264 streams. Then there is a category of devices that could receive only either H.264 ladder or HEVC ladder, but you cannot switch between them.
Okay.
And that will include majority of Dash devices, even though in Dash there is a way to enable switching across adaptation sets by using so-called supplemental property, but only few players realistically support it as of now. But then there is a 3rd category of devices that can play both codecs and then can switch between them simultaneously and seamlessly. That's most new Apple devices. And if you realize that there are these 3 categories of devices that exist, turns out that you can generate ladder that will be optimal when you stream to a mix of these 3 different categories of devices, such that you don't need to use twice many streams.
Which is what Apple recommends.
Yes. And why you don't need to use twice many streams is because you could reuse H.264 streams if you just putting them in intermediate positions between HEVC streams. You could see that by following intelligently picking those bit rates, you can actually have a better approximation of rate distortion curve going from worst quality to the highest quality and picking different codecs across. And this gives you finer grain adaptation for those devices that can switch seamlessly between those codecs.
HEVC is a more efficient codec, so shouldn't that get screwed up at times?
Well, if it would be efficient like by 75%, that probably would prevent this from happening. But if it is only better by 10 or 15 or 25%, which we see for number of content, it actually becomes a situation when you can effectively switch between those.
Do you have the actual encoding ladder in a table on the next
yes,
slide?
This is just an illustration of rate allocation. For this particular example, I don't have another slide to show.
Oh, so you don't have the ladder for us. That's what I wanted.
Yeah.
Okay, cut the interview. We don't have this. I'm teasing. Can you show us those rates or get us?
Yes, I could.
Can you present? Can I somehow get a ladder from that?
Yes, of course. This is actually published. There is a paper with all this.
So I should be able to figure it out.
Of course, but even from the numbers that we could see here, I would say that this rate, for example, and this is encoded in H.264, is about 300 kilobits,
okay.
and the next that goes.
I'll send a table to you, and then you say it's either totally off base or not. Okay, so it was probably 2.5 years ago, at the end of 2015, when Netflix came out with per title encoding, and the encoding ladder was dead, and now it looks like per title encoding is on the way out for a more holistic approach that incorporates all the elements that Yuriy talked about during his talk. So listen, I really appreciate. He's got some lovely white papers out there, but they're challenging for non-math majors like me, and I appreciate you taking the time to explain it to us.
It's my pleasure. Thank you so much.
Okay, signing off from NAB. I'm Jan Ozer. Thank you.